Alrighty, so now we have covered the properties of combinations, its basic definition, and some examples. We're ready to talk about the binomial theorem. Many of you probably have seen this before, okay? Especially in calculus 2, I should say. The binomial theorem, I mean, the result is seems pretty straightforward, I should say. You have the left-hand side of a plus b to the power of n, and right-hand side is a sum, as you can see, of like a term, each term seems to include a choose function, as you can see, and then some power over here, okay? So the proof of it in a different course, for example, could be mathematical induction, like you consider a special case of n equals to 1, 2, and then with the n minus y case, you can use the n minus 1 result to prove the result of the case of n, okay? And in this course, in this particular lecture, we're going to focus on the combinatorial consideration. And you can see that, well, the choose function is involved, right? So maybe one way or another, some kind of combinations is happening. And that's what we're actually going to go for. And to do that, we're going to introduce an example first, okay? So remember, we talked about the license plates early. And we're talking about, I think back then we have 6 digits, right? The first 3 can be letters and the last 3 can be numbers. And then we're thinking about the number of ways or the number of distinct license plates you're able to have. Here, we have a different scenario, okay? We are saying that the license plates generically are being formed by n digits. And then each digit could be a letter or a number, okay? So we're not restricted to only letter or number anymore. It can be either or, okay? So I'm putting it now, a equals to 26 and b equals to 10. You will see soon why that is the case. But this is really trying to figure out like the number of ways we're able to have the distinct n-digit length license plates with each of them could be a letter or a number, okay? So the left-hand side, if we think in that way, well, the left-hand side is really what we talked about based on the generalized rule of counting, right? If I have n digits and I can fill each digit with either a number or a letter, then I have 26 plus 10, which is left-hand side, as you can see here. And then that's the number of possibilities I can have for each of the digits. And I have n digit, right? N digits in total. So I just multiply all of them based on the generalized rule of counting. And then it becomes clear that the left-hand side refers to the number of distinct license plates I can have, okay? So the right-hand side might still look a little bit evolved, complicated, and you might be wondering, okay, what does it mean? Why the right-hand side actually also, well, based on our reasoning before, the right-hand side should also indicate the number of distinct license plates we can have, right? All right, so let's see why that is the case. So first of all, we know that, well, it is a sum, right? It is a sum of n plus 1 items because you have k from 0 to n, so there should be n plus 1 terms add up together. So one way to think about it, keep in mind that we also know that the right-hand side refers to the number of total number of distinct license plates. So one way to think about it, okay, is to, especially now because we know it's n plus 1 different sums add up together, different terms add up together. So let's just break it into n different sums for now, okay? But keep in mind, we are labeling each item with a subscript k, okay? Each nk is the number of distinct plates that contains exactly k number of letters, okay? So bear with me for now, okay? We're focusing on nk being the number of distinct plates that contains exactly k number of letters. Okay, so maybe that starts to hopefully ring a bell a little bit of, well, now we start to going to talk about those specific terms of how to get it. And then as you can see, once we break it into the sum of n plus terms, and each representing exactly k number of letters, then the remaining task is to understand why this whole thing represents the number of ways, right, to have a number of license plates with exactly k number of letters, okay? So remember, our license plate has n digits, okay? And n digits, we need to have k number of letters. And to do so, hopefully start to make sense, right? To do so, we first of all have a choose function of choosing k places or k locations for the k letters, okay? And then once we have done that, well, we still have to choose choose the letters, right? So there are K, so let me start, I guess, showing this. So this is the choose function, right? Where this is a number of combinations, okay? But then it's not like this particular task has not ended yet. Because in addition to choose the locations, we still have to fill that K locations with letters, which has A, right? 26 number of choices, and it's K of them. So you raise to the power of K. And then the remaining n minus K location needs to be numbers, and there's 10, which is B, to the power of n minus K. Okay, so with all of this in mind, hopefully it starts to make sense that this NK is representing the number of distinct license plates you're able to have with exactly K number of letters. Okay, and the right hand side is trying to finish the task one step at a time, right? We do a choose function that's just choosing the location. It's a combination. But then after that, we also need to determine how many ways, right? We are able to fill K letters, and then the number of ways to fill the remaining n minus K numbers. And we do multiplication because of the generalized rule of counting, right? Because each of this is only one step to complete the task, and we multiply them together to get the total number of possibilities. Okay, so binomial theorem hopefully now starts to make more sense to you. Okay, there are many different ways of using the binomial theorem, not only in our course, but in other contexts. But here, please make sure that you understand what the binomial theorem is about, but at the same time, also how to use a combinatorial consideration to prove the binomial theorem. And later, you'll be able to get the chance to do more exercises about how to use them.